Hi everyone, welcome to the project on machine learning foundations for product managers. I will walk you through the course project in the next few minutes. The project topic is that we've been asked to predict the electrical energy output of a combined cycle power plant, and we've been given a data set of 9568 observations or readings. The features that have been mentioned are temperature, ambient pressure, relative humidity, and exhaust vacuum. These are the features or the independent variables, and the target variable that we have to predict, or which is the dependent variable, is the electrical energy output. We've been given a few guidelines as to how to proceed about the project, and my selected method for today's modeling process is Microsoft Excel. So, taking you through the model selection and the modeling process, the ML approach that I have selected is multiple linear regression model because the number of features that have been provided are more than two, and the features are numerical in nature, so they pretty much have almost a linear relationship. That's why multiple linear regression is my preferred choice. I have selected two models. The first model, I have selected all features, which are the four given features. And in the second model, I have selected three features. Out of the four features for the second model, based on the correlation matrix that I will display within a few seconds, I have dropped one variable which had the least correlation with the target variable PE, and that was my choice of selection for the second model. I have used a fixed validation set and have split the data into 80% training set, 10% validation, and 10% test set. The validation approach I will be using is R squared, and depending on how the model performs, the model with a higher R squared value indicates that the model is a better fit to the data. The model evaluation metrics that I would be using is mean square error and root mean square error. This is a display of the data for the today's project. AT, V, AP, RH, all these are the independent variables. PE is our target variable. I have constructed a correlation matrix on these given data points, and based on the matrix, I have seen that RH, or relative humidity, has the least correlation with our target variable PE. So RH has been my choice variable, which I have dropped in the second model, and I have used only AT, V, and AP in my second model. The given models, like I mentioned, it are the temperature, ambient pressure, relative humidity, exhaust volume. These are the independent variables for today's data point, and the target variable is PE, or the electrical energy output. This is a snapshot of the training data set as well as the validation data set for model 1. For model 1, I have used all the four features that are given in the model. I have used the data analysis tool plugin in Microsoft Excel and generated this regression output analysis. As you can see, the R square value is almost close to 93% on the training set, which basically tells that 93% of the variance in the target variable can be attributed to all four given features. This is a pretty good fit because of it. This is a very good high value of the R square. Next, I have run the same regression on the validation set, and I have seen that the R square is almost similar to the training set, which is very close. Slightly, it's 92%. So I can again say that the model is a good fit with a very high R square value even on the validation set as well. Second is the model that I have decided is the second model, where I dropped RH, or relative humidity. So now I have three features and one target variable. Again, running 80% training set, I ran the regression where I found there's a very minimal change in the R square as compared to the first model. Here the R square is 92%, which says that the variance is kind of 92% on the three features that I have selected, or the independent variables. Similarly, for the validation set, which was 10% of the entire data set, the R square again is closer to the training set, which is coming to 91%. still quite close to the values that we have seen for the model 1. So I have done further analysis on both these models, like calculating metrics like mean square error and root mean square error. And based on these metrics on both the models, I have seen that the validation set performs better in the model 1, because as you can see, the mean square error is less for the validation set on the first model as compared to the second model. That is the same trend that is followed for RMSE for validation sets on model 1 as compared to model 2. So depending on these metrics, we can say that the first model performs better on the validation set, which means that it is a better fit to the given data set for today. Hence, I have gone ahead and selected model 1 as my preferred model for this project. Once model 1 was selected, that was the final model that I chose, I ran the test set of 10% of my entire observations and to calculate the R square, the MSE and RMSE. I can see that the R square is pretty high and compares well with the training set and validation set on the model 1, and also the mean square error and root mean square error values are also the lowest when we ran this test on the test set. Hence we can conclude that the model 1, based on all the regression analysis that we did for today, model 1 is a good fit for the given data set. Thank you so much.